This is your Chapter 3 notes on linear equations and functions, starting at page 2. And the reason it says Section 2.2 up at the top is because we have to go back and review some really important things that you guys have learned over the years, but are crucial for you to understand this chapter and where we're going with linear equations and linear inequalities. So remember, we have a solution point. This is also known as an ordered pair, or some x comma y, which makes the equation true. Remember, this is super important for us. We're always looking for what is true. What are true points? So an x or a y. We're also going to talk about linear functions. And where a function simply means that you have the input and the output, so that every input has only one output. And linear means it's going to be a line. So some input output relationship which creates a line. For example, you might have y equals 3x minus 6. That is a linear function or a linear equation. It can also be written as f of x equals 3x minus 6. How can we tell that it's actually a function? You can plug this into your calculator. Remember, the piece you would plug into your calculator would be the 3x minus 6, because the f of x and the y's are the same thing. Plug that into your calculator and do a vertical line test. When you do that, so let's say over here in the corner, we graph this and you put it into your calculator, or you can do our special graphing trick where we start with the negative 6 and slope up 3 over 1 every time. And we're looking at this line here. Okay, we talk about x-intercepts and y-intercepts. An x-intercept is where the function or the equation crosses the x-axis. So for this one here, this would be the x-intercept right there. And the thing about an x-intercept is that it's always going to have some form of x. We don't know what the x is maybe, but then it's always going to be 0 for your y. Think about this. Any dot on this line, any dot on this x-axis all the way across, y is always going to be 0. So it's also very important we note here that the x-intercept is when y equals 0. That's huge for us. And then we also have y-intercepts, which is the same thing, where the equation or where the function crosses the y-axis. So for us, that's down here. This is the y-intercept. And this one will always have the form of 0, comma, some y. Remember, any point that crosses this y-axis, x is always going to be 0. So we say when x is 0. Also very important for us. We also talk about slope. And slope for us is the change in y over the change in x. That's something you've probably seen from Mr. McDonald's class. Or we say that it's rise over run. Just the way I counted with my 3, I went up 3 over 1, up 3 over 1. That was the rise over run. The formal formula for slope is this one. M is the change in y over the change in x. So y2 minus y1 divided by x2 minus x1. This you must have memorized. You have to know this guy, okay? So you need to know him. We're going to look at a couple of examples of how do you write equations of lines. And in order to write equations of lines, we also have to know our slope. So keep your slope formula handy, and we're going to practice really quick. Find the slope of the line through the following pairs of points. So for our first one here, m equals, and then we want to make sure that we catch, if these are our y's here, and these would be our x's. We're going to make sure we put the y's up top, and we're going to make sure that we put the x's on the bottom. So we're going to say 7 and then minus a negative 6. It's really important that we keep these pieces together. So when I put the 7 here, I put negative 2 here, and then I put minus 8. So 7 minus a negative 6 becomes 7 plus 6, or 13. Negative 2 minus 8 is a negative 10. And then I ask myself, can I simplify this at all? There's nothing I can think of for 13 and 10, so we just leave it as negative 13 tenths as slope. Next one over here. M equals, and the y's on top, so 8 minus 8, so 5 minus a negative 3, which gives us 0 over 8. Remember that 0 over anything, that's just 0. So for us here, slope was 0. This is also important that you memorize this, anything with a 0 on top, becoming a 0. And then let's do another one. M equals 11 minus a negative 6. So 2 minus 2. 11 minus negative 6 is 11 plus 6, so 17, all over 0. Now this slope, this is undefined. Anytime you have a 0 on the bottom, 0 on the bottom of the fraction makes an undefined slope. That's also really important you memorize it. When we talk about slopes and what they look like, think about what this looks like in a picture. So if we have 5 comma 8, and if we had negative 3 comma 8, the line is doing this. This is what a slope of 0 looks like. It's a flat line. However, when we have 2 comma negative 6 and 2 comma 11, this is our line. And you can see automatically it's not a function because it doesn't pass the vertical line test. It is an equation though. So we'd say equation, not function. And that's the undefined slope is when we head up and down. So think of it this way. Think of as not functions are always going to be with your undefineds for these lessons. Now what are the different ways we can write a line? Because there's lots of different ways. So 3 main ways that you need to know, and you also need to memorize these as well. General form is when you have ax plus by plus c equals 0. You sometimes see this also written where it's ax plus by and the c is moved to the other side. That's another way you might see this. Remember the a and the b and the c would be coefficients of some sort or in a constant, and then your x and your y are your variables. Slope-intercept form, this is y equals mx plus b, where this is your slope like we just saw in our equation above, and this is your y-intercept, which we talked about on your first page. Then we also have point slope form, y2 minus y1 equals m times x2 minus x1. This is again your slope. And then you would have some point, some ordered pair for the y1 and the x1. Not for both pieces necessarily, but just the one. This also represents a point, but you have to leave some variables there, just the same way that we left some x and some b for the equations to work. Now, you're going to come across those different types of equations in these lessons, and how do you graph them? This is also important. So 3 ways: general form, slope-intercept form, point-slope form. So for general form, if you were to graph this, here's an example for us. If you have a general form equation, what you want to do is, some people call it the cover-up method, but what you're really doing is you're plotting the intercepts on the axes. So you need to start by finding the x and y intercepts. Let y equal 0. Remember, when y equals 0, you're finding the x intercept. So 4x plus 5 times 0 equals 20. 5 times 0 is just 0. So 4x equals 20 gives you x equals 5. That's what I mean by the cover-up method. Someone would have covered up the 5y and just solved for x. So on your graph, 1, 2, 3, 4, 5. There's your x-intercept. And then we also need to get the y-intercept for this one. So we'd say also over here, let x equal 0. That gives you the y-intercept. So 4 times 0 plus 5y equals 20. 5y equals 20 gives you y equals 4. And then when we go ahead and join those, that is the equation 4x plus 5y equals 20. And that is a general form equation, just like we just saw in the beginning one. The next one, slope-intercept form, this is the easiest one to graph. This one is so nice for graphing. This is where you see something like y equals negative 2/3 x plus 4. And the reason this one is so nice is we look at the y-intercept first, in which case here we have a plus 4. So 1, 2, 3, 4. There it is. And then we look at our slope. Remember, slope is rise over run. When you have a negative slope like this with negative 2, instead of going up 2, you go down 2, and then you go right 3. 1, 2, 3. So down 2, right 3. So nice, so quick. We don't have to solve anything. So we really like that one for graphing. The other one for graphing that's really nice that we like is the point slope form, this very last one. This would be where you had something like, say, y minus 1 equals negative 1/4 x plus 3. Now with this one we have to be a little more careful. We're going to do something similar where we start with a point. And then we're going to use slope. However, the point in this case is always opposite whatever is given to us. So if you have a plus 3 here, that really actually becomes negative 3, and this negative 1 changes to a positive 1. So please watch out for that. That's very unusual and something we have to be careful of. So we're going to get negative 3, 1, 2, 3, up 1, there it is. And this one also has a negative slope. So down 1 over 4. Down 1 over 4. And that's how we graph something in point slope form. This is still chapter 3 in your notes, and this is a continuation of lesson 2.2. So this is lesson 2.2b that we are continuing right now. And we want to talk about slopes and writing lines. So when you see a slope of m, we talked about this before, this is a horizontal line. Okay, no up, no down. We also talked about vertical lines, and this is when the slope is undefined. And what we mean by undefined is that you'll have m equals some number, we don't really care what, but some number over 0. That's an undefined slope. Whereas m equals 0 over something, any number, that's the 0 slope. Okay, so watch out for those two. When we talk about perpendicular lines, we remember this means they meet at a right angle in here. That also means that their slopes will equal negative 1. So this is what we call opposite reciprocals. Opposite reciprocal slopes. And then we have parallel lines, meaning they never touch, and this is when your slopes are equal to each other. So we're going to use these today in our lesson. First of all, write an example of a vertical line through the point 2, 3. I always like to kind of visualize what's going on here. So if I have a point through 2, 3, and it says a vertical line, so that means it's running straight up and down. This would be the example of our undefined line right here. And if you look back up at your chart, we saw that the equation in that box was some x equals something. And again, this line is running through, and all of these points on this line, all of the solution points, all of the ordered pairs are going to be 2, 5, 2, 4, 2, 3, 2, 2, 2, 1. Notice that all the x's are always 2's. The y's change. We don't care what the y's are, but we're running straight up and down. So vertical lines are always going to be x equals whatever this is. So x equals 2. Then we have a horizontal line, and this goes through the point 6, 1. This is an example of that zero slope, and if you look back up at your chart, we saw that this one has the y's. This is going through all the y points of y equals 1. So horizontal line, y equals whatever this is, just 1. So notice that these two here are single variables, right? They're still lines. Don't let it throw you. They're still lines, but they just have funny slopes. This one has that slope of 0, and this one would have that undefined slope. So that's why they look a little different than those 3 special equations we looked at before. If you look back at page 3 in your notes, we talked about what point slope form is, and that's important for us to know. Point slope form is y2 minus y1 equals m times x2 minus x1, and we want point slope through each pair of points. So this is going to be like part A, and this over here is part B. In order to get point slope form, we need to find slope. So start by finding slope. Slope is -5 minus 3. It means the -2 must go under the -5, and then minus a -10, which gives -8 up top. And over here at the -10, a negative times negative becomes a positive. -2 plus 10 becomes positive 8. So slope is -1 for our slope. So that's our slope. We can use either point. It does not matter. So we could write the equation as being 3. Well, we could write the equation as being y minus 3 equals -1 x plus 10. Again, remember, because it's minus a negative, that would be one answer. Or you could also say y plus 5 equals -1 x plus 2. That is also point slope form for the exact same line. This one over here, find your slope. So 1 minus a -3. 7 minus a -4. This becomes 4, and this becomes 11. So slope is 4/11. Y could equal plus, let's see, y plus 3, 4/11, x plus 4, or y minus 1 equals 4/11, x minus 7. So that is point slope form. Now we're going to talk a little bit about the whole parallel and perpendicular idea. And usually when we talk about parallel and perpendicular, they give you a line. So here they've given us this line both times. And what we're going to do is we're going to write the equation of a line through a certain point. So the line must pass through these points, but it must also be either parallel or perpendicular to a line we've already been given. Now when you have a point here, that's great. What else do we need? We need a slope. So when we're looking at a parallel thing, look at the slope, because this is in your y equals mx plus b form right here. So we can see that our slope happens to be positive 4. And once we have our slope and we have our point, we could do point slope form. So we could say y minus 2 equals 4x minus 1. That could be the equation right there. Give the x-intercept for this. Well, remember, x-intercepts means let y equal 0. That's what an x-intercept means. So we'd have to say 0 over here, negative 2, 4x minus 1, and keep solving. So negative 2 equals 4x minus 4. Let's add 4 to both sides. So we get 2 equals 4x. And when we divide both sides by 4, we get 1/2 for x. So the x-intercept would be 1/2, comma 0. So that's the second part of our answer. Here's the equation we wrote, and here's the x-intercept of that line. So if you were to plug this into your calculator or graph it by hand, this is where you would see it crossing the x-intercept. Now this one here, write the equation of a line through and we get a point perpendicular to. We're still interested in this guy. That's still the slope idea. The slope of this line is 4 for this equation. When we say perpendicular, we're no longer sharing the same slope. We now want the opposite reciprocal. So the opposite reciprocal, or the perpendicular slope, would be negative 1/4. That's the slope we're going to use here. Whereas up here, this was the parallel slope. So here's your point. Here's your perpendicular slope. Y plus 1 equals negative 1/4 x minus 8. That's the equation. Now, this time it asks us to go a little further and to give the x and the y-intercepts. So for this one here, an x-intercept again is where y equals 0. So 0 plus 1 equals negative 1/4 x minus 8. So 1 equals negative 1/4 x plus 2. Subtract 2 from both sides. Negative 1 equals negative 1/4 x. Now, we still want x by itself, so to get rid of this, let's go ahead and let's multiply both sides by negative 4 over 1, negative 4 over 1, because then we cancel the 4's, cancel the 1's, cancel the negatives. Negative times a negative is positive 4 equals x. So the x-intercept is 4, comma 0. And then do the same thing for your y-intercept. So where we let x equal 0. So we get y plus 1 equals 2, subtract 1, y equals 1. So we get the point 0, comma 1 as your y-intercept. Okay, so parallel and perpendicular slopes, x and y-intercepts. Now the last two examples didn't specify what type of equation we had to write. This time we're going to specify that we must put our answer into slope-intercept form. And again, slope-intercept form is that one where it's y equals mx plus b. So here's the equation. We must get it to look like this one, and then it wants us to find the slope and the intercepts. So if we have negative 3x minus y equals 2, it actually just means we have to get y by itself over here. So if we can add the 3x to both sides, we have negative y equals 3x plus 2. And to get rid of this negative, just means that we'll multiply both sides by a negative 1. So we get y equals negative 3x minus 2. There's our equation. Now the slope, hey, look at that right there. Slope equals negative 3. Yay. And to find the x and y intercepts, x-intercept means 0 for y. So our x-intercept will be negative 2/3, comma 0. That's the x-intercept. And then for the y-intercept, this goes away to 0. Y equals negative 2. So we get 0, comma, negative 2. And again, negative 2 we could have seen from right here. This is your y-intercept there.